Chapter 1 test, Form A. And so it says find the average velocity between 0.25 and 1. And 1 was 8, and we take the farther one minus the beginning one, and that comes out to be 1.45 over 0.75, which is 1.933 meters per second. Meters per second. Find this using the central difference. 1.25 is here, so we're going to do the 14.13 minus 8.00 over 1.25 minus 1.50 minus 1.00, or that's 2 times 0.25 because I went 0.25 above and below. And so we get 6.13 over 0.5, which is approximately 12.26. That's also meters per second. That's the slope of the distance graph. And then C, the linear approximation to get something near 1.25, 1.23, we would use A as 1.25. So we need the derivative, and so we'll use part B because that's the derivative at 1.25, and that's 12.26 times x minus A, which is 1.25, plus f of A, which is 10.36. 10.36. And then we would put in the 1.23, and so the difference here would be a minus 0.02. We'd take it times that. We'd get negative 0.2452 and add the 10.36 to get 10.11-ish. And this is a linear approximation of the distance graph, so this would be in meters. Number 2. And so the bank balance is this. What is it at B equals 20? So we're just plugging 20 into this equation. And when you do that on your calculator, you get 3319.30-ish. And that would be 20 years after 2000. So is the balance in 2020. B prime, using the limit definition. So that'd be the limit as h approaches 0 of this 4200 times 1.04 to the negative 0.3. And for the t, we're going to put in, we're trying to find it at 20. 20 plus h minus 4200, 1.04 to the negative 0.3 times 20 all over h. And several people had that right, but when they typed it in their calculator, they did something wrong. So I'm going to clear all those and type it in, and I'm not going to use some of the fancy features of this nice calculator, so I'm going to say, I'm going to open my parenthesis, and then I'm going to put for the numerator, 4200, parenthesis 1.04, close parenthesis, 2. Now this goes up. on this fancy calculator. Now, if you're using an old one, it doesn't go up, and so you have to put parentheses around all of this. If you didn't do that, you'll get the wrong answer. But since this goes up, I don't need them. But I'm going to put them on there just so that those of you who don't have the one that does this pretty notation, you'll need to do minus 0.3 parenthesis 20 plus x, close parenthesis for that, close parenthesis for that whole numerator. Now, on this calculator, you don't need that outside set there. This one and this one. But on the older calculators, you would. And on some of the other ones. We got minus 4,200 parentheses 1.04, wasn't it? Yes. Close parentheses to the, once again, since if you had an older calculator, you would have to start with parentheses, minus 0.3 times 20, and close the power, come down, close the whole numerator, divided by x. And then we want to look at this close to x equals 0. So second table, and I don't need that one, but I want to look close to 0, and these are close to 0, and I'm getting negative 39.06. And I want the units on this, and so the numerator is in dollars, and the denominator H is in years, years. So the sentence, this is saying the balance is decreasing $39.06 per year in 2020, or 20 years after you started. Is B prime, double prime positive? Well, this is an exponential. So if I were to graph that equation, you can't see it there. I have to work on my window. So I'm going to go, it's in there. Oh no, that's the derivative. I need to put the equation in. So I'll turn that one off, come down here and turn on 4,200 parentheses 1.04 close parentheses to the negative 0.3x. If you were on a regular calculator, or the older calculator, you'd have to put all that in parentheses. Graph. Do I see it? No. On. Zoom. Standard. Do I see it? No. That's because I'm not looking in the right places here. So window, I need to look from the years being 0 to 20, and I want to look at the bank balance is somewhere between negative 10 or 0 and probably more than 4,200, so I'm going to go 5,000, and I'm going to step that by every 1,000. So I'm going to have 5 vertical marks. Graph. And there it is. And if you hold it up this way, it's still pretty hard to tell. If I look out further, look for longer, so for 0 to 50 years, you might get to see a little bit better what's going on with it. And if you look down the line this way, you can see that it's curved up. So B double prime has to be positive. And I could say from graph. If I could also say exponentials, exponential functions curve up. And that's true whether it's got a negative exponent like this one does, which is curved up but does this, or if it was a positive exponent, then it would curve up this way. Exponentials always curve up, unless there's a number in front that flips the thing over, then they would curve down. But they always curve up. Okay? You could say that. And then determine the equation of the tangent line. So line x at, and we're doing it at 20 years, so a equals 20. We need f prime at 20, which we figured out to be negative 39.06, parenthesis, number of years, maybe t or x, minus 20 years plus f at 20, which we figured out in the first one, 3319.30. And the units on this would be dollars if you were ever curious, because we're approximating the balance. Okay, page 2. There were some interesting things for this, but we'll see what we can do with it. All right. So if I were looking at this, I've got a negative slope here, so I'm going to make a little pinwheel here for me to kind of estimate. There's no slope. There's a slope of 2. So there's a slope of 1, and there's a slope of a half, and there's a quarter. If I go the other way, there's a slope of 2, and there's a slope of 1, and there's a slope of a half. So this first part looks a little steeper than 2, maybe a slope of 3. And it's pretty consistently 3 in the negative direction. These are all negative on this side. So I'm going to have negative 3 starting about negative 7. It would be negative 3, and it holds negative 3 clear up to about negative 4. And then the slope goes to 0 just before 2. And this is kind of parabolic in shape, so it would be kind of linear here. And it gets clear up to a pretty good size slope, maybe 3 or 4. And then it's got a sharp bend there, fairly sharp, so it's going to quickly go down to this slope, which looks like about 1, holding 1 for up to 3, and then it goes to 0 by 7, and down, and this is sort of a parabolic shape, so I will kind of just do a 7 and going down. Something like that. Then the slope of this one, slope here is 0 up to 4, and then it goes up to maybe a slope of 2, and it gets there fairly quickly, holds the slope of 2 for almost up to here. Then it goes almost to negative infinity, shoo, way down there, very steep down. And then it comes back to a slope of 0. And then it goes to a slope of maybe negative 1/4 or something at 3. And then it just kind of holds that slope. So the zeros here is a min. The 0 here is a max. F prime of x equals 0 tells max and mins of f of x. Slope is 0. What do the zeros of this one tell us? Well, this 0, these zeros are where it's straight. in the original function up here. And this 0 is when this is straight. And this 0 is when the curvature changed. And this is when it starts curving again. So if there's a section on this line, f double prime equals 0 could be a change in curvature, or f in curvature of f, or f of x is linear. Wherever it's a fairly straight line, this is 0. Wherever it's a straight line-ish, it is 0. And how do I know that this is curved up from -4 to 0? The second derivative is positive. Or the slope of the first derivative is increasing. The value of f is increasing, not the slope, but the slope of this is a positive slope. Or f prime has positive slope. Okay. Next page. Remembering my rules. Limit, there has to be your left and right, and they have to be equal. Coming at -6 from the either side, they both go to 3, so it exists. So I determine the following if they exist. The limit of this is 3. That's 0. Both of them come in. The left and the right both had 2, -2. Plus 4. 4 from the plus side. That's headed to 2. And the limit at 4 is undefined because does not exist, if you will, because the left and right limits are not equal. This one is 2, this one is -2. So then, same function. What about at -6? Is it continuous? Well, it has a value, it has a limit, but they are not the same. The limit's here, the value's there. So not continuous because limit does not equal value. At x equal -3, it has a limit, -1.1 or 2, has a value, -1 or 1.2, and they're the same, so continuous. At x equals 0, has a limit from the left and right, but it has no value. So not continuous because no value. And at x equals 4, it's not continuous because at 4, it doesn't have a limit. Because it has to have a limit, has to have a value. It has a value, but it has no limit because left and right are not the same. Because no limit. That was said in that one. Differential at 0. Well, it has to be continuous at 0. And we said it was not continuous. And it can't be a cusp. Well, it's not a cusp, or it might be a cusp. There's a slight bend there, but it's there's no value, so it's not continuous, and that's the key thing here. So it's not differentiable because not continuous. Okay, last page. And so if we're going to use the limit definition, that'd be f prime of 3 is equal to the limit as h approaches 0 of this function with 3 plus h and then with just h. So it's going to be 3 plus h squared cosine of 3 plus h minus 3 squared cosine 3 over h. And I'm going to type that one in because some people had trouble with that. Going back here, and we're going to type in open parenthesis for the numerator, open parenthesis for the 3 plus h, which we need to make an x, close parenthesis, squared cosine 3 plus x. They've already put a parenthesis, so I just got to close that, minus the second part. Now, if you're putting parentheses on this, you can do that, and you can do it here, but you need one for the whole numerator, so an extra one there then. I'm not putting them on these because this is all multiplied, so I don't need to worry about distributing the minus. So I'm just making sure I've got a parenthesis for the whole numerator. So it'd be minus 3 squared cosine 3, close parenthesis for the cosine, close parenthesis for the numerator, divided by the denominator, x or h. And then I got to look close to 0. And I've done that before, and I'm getting negative 7.21. Okay. And then finally, let's see here. Oops, got the wrong one here. I was just checking my answer, make sure I didn't make any mistakes. Negative 7.2. Yep. And now this one. Determine equation of the tangent line. Well, that's a linear approximation at a equal 5, it looks like, because that's where we got all our information. And so we're going to go f prime at 5, which is negative 7, times x minus 5, x minus a, plus f of a, which is 21. Done. And that's your part to do 5.1. So we put 5.1 in there. 5 from 5.1 is 0.1 times negative 7. That would be negative 7 times 0.1 plus 21. So that's negative 0.7 plus 21, or 20.3. And finally, is this value expected to be an over or underestimate? And they said up here that the second derivative is positive, meaning this is curved up. Wherever it is, it's curved up. And whether we're on the tangent line here or tangent line here, the line is going to give you values. This line is going to give you values that are under the curve. So under estimate, because f double prime is greater than 0. That means it's concave up. Okay. Oop, I didn't show that here, so let's go down here. Sorry. So Positive for the second derivative, which means the line, no matter if it's there or there or there, the lines, if you move off of where it's tangent, is going to be under the curve. So you're going to get underestimates because the curve is curved up.